Welcome back everyone to Theory B of 4.2 calculations with square roots, and here's where we're really going to work with, calculate with, and later on in this chapter also simplify with square roots. If I take a look at the square root, you can say that the square root is the inverse of a square. If I want to calculate what 5 squared is, I do 5 times 5, and that's 25. If I take the square root of 25, that's actually asking yourself this question: which number times itself is 25? That's 5 in this case, right? Remember, and we're going to take a look at this later on as well, that I can square minus 5 to find 25, but we cannot say that there is a square root of minus 25. They say the square root of a number is not negative. Later on, we'll take a look at why that's the case. Calculating square root is called taking the square root, worteltrekken. In the order of operations, roots come before multiplying and dividing, but after the brackets. You do them in the same order as squares, actually, squares and square roots. Let's take a look at a few exercises. The square root of 9 plus 16. If I want to calculate this, I have to calculate what the square root of 9 is. And the square root of 9, that means which number times itself is 9. It has to be 3, right? And if you have 3, then you can do 3 plus 16, and you will find 19. Okay? B looks a lot the same, but at B, the square root is also above 16, which means that I first have to add 9 and 16, which gives me 25. Which number times itself is 25? That's 5, right? So the answer here is 5. Take a good look at C. 4 square root 9 plus 3 square root 16. What's right here is actually 4 times square root 9 and 3 times square root 16. So first calculate the square root of 9. That's 3, right? And the square root of 16, which is 4. And then my intermediate step is 4 times 3. There's actually a multiplication dot here. Plus 3 times 4, which gives me 12 plus 12 is 24. Alright? Then at D, first do the addition. Then you get 16,900. Here you have to not watch out actually, you have to know your squares well. Because I don't know maybe mentally what the square of such a big number can be. So maybe you think you have to take out your calculator here, but you don't have to. Because I know that, for example, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169. So 13 times 13 is 169. But I have 2 zeros extra. Well, don't you worry. That means the answer is 130. 130 times 130 gives me 16,900. Okay, so know your squares up to and including 15, please. And then sometimes you can use it on bigger numbers like this as well. And let's see, can I already take a look at this as well? I think I can. If you want to calculate square roots of fractions, you don't have to worry here. What I always imply you should do, if you have a square root of a number on top and on the bottom, that's the same as the square root of the whole number. So take the square root of the numerator and take the square root of the denominator. Here, those you can calculate. That is 2 over 5. And here you have some other examples as well. If you have a fraction that has been that is a mixed number, so it has numbers outside of your fraction, first put them back into the fraction, right? Make it a fraction again. Then take the separate square roots of the numerator and denominator and then simplify again. Okay? And you can do this for square roots of decimal numbers as well. And here's a trick that you have to use. If I want to calculate the square root of 0.25, remember I can write 0.25 as a fraction. Which fraction? Well, that's actually 25 divided by 100. Hey, and here I know what the answer is, right? Because here I can take the separate square roots, and that would give me, in this case, 5/10, or you can say a half. Here another example of 1.96. First write it as a fraction, then take the separate square roots, calculate those, and then simplify again. In this case, go back to mixed numbers. Okay? And that's chapter 4.2 really. So know the rules, know when you have to square, know what a square root is and what the square root does, and know how to apply them on fractions and on decimal numbers. Good luck.